So in this question we're going to use differential geometry to find the radius of curvature of this cubic equation here. So y equals 2x cubed minus 3x squared minus x plus 4. And we want the radius of curvature at the point where x equals 0. When we've got that radius, we want to find the equation of the circle that radius makes. So we're going to use differential geometry. Now, using differential geometry to find the radius of curvature, what that means is, what's the largest radius of a circle that we can get at the point x equals 0 to fit inside that curve. So using differential geometry, what we do is first of all use the radius of curvature equation. We have the Greek letter rho, and that equals, now it's absolute values and it's a ratio, and it's the ratio between 1 plus the first derivative squared, and that's all raised to the power of 3 over 2, so it's cubed, and then we take the square root of it, and then we divide that by the second derivative. So that's d squared y dx squared. Okay, and then what we want to do to find the radius of curvature at x equals 0, we just evaluate this at x equals 0. So that's pretty much what happens for this radius of curvature part of the question. So what we're going to do here, first of all, let's get our building blocks for this equation and find the derivative and second derivative of this. So dy dx of this, well, that's going to be, using the power rule and the sum rule, 6x squared minus 6x minus 1. And then evaluating that at x equals 0, because that's what we want. X equals 0, then y equals, well, they will cancel out, so we're left with minus 1. So that's pretty straightforward. Now we want the second derivative. So second derivative of y, that's just going to be the derivative of that, which is going to give me 12x minus 6. This one will disappear, and then again evaluate at x equals 0. X equals 0, if that's 0, we're just left with minus 6. So that's pretty straightforward for our building blocks. Now let's go into this. So now rho is our radius of curvature. That gives us 1 plus the derivative squared at x equals 0. So minus 1 squared. So we've got 1 plus minus 1 squared. And then what we do is, with that we want to cube it and take the square root. So that's how we can write that. And then we divide that by the second derivative at x equals 0, which is minus 6. Okay, now let's go through this pretty carefully. 1 plus minus 1 squared, well, minus 1 squared is 1, so that gives me 2. 2 cubed is 8. And then on our numerator we've got square root of 8. So we've got square root of 8, and that's divided by minus 6. So we can rewrite this. Let's take the absolute value of that, which will then eliminate this minus sign. So then that equals, square root of 8 is 2 root 2, and then we got the left with the 6. And then we can cancel the 2 with the 6 and just leave the 3 in our denominator. So therefore the radius of curvature, rho, equals root 2 over 3. So that's the length of our radius. Now if you plug that into a calculator, square root of 2 is just over 1.4. So 1.4 divided by 3, that's going to be just less than a half. So just give us some indication. I'm just going to write that there as a guide to what we're kind of looking at here. So we've got a radius of a circle which is only 1/2, or just under 1/2. Okay, now we've got the radius of curvature. Let's have a look at the equation of the circle that will make. So let's take this off the board. So with the radius of curvature, we now need to find the equation of a circle. Now, if we know that that's, well, this value here, that's the bit we're interested in. That's our approximation. This value here is the radius, and we know the derivative is minus 1 at x equals 0. What that means is the gradient of that is -1 at x equals 0, which means that's the slope. So what we can do is, if we know where the tangent is and we know the slope, if we find the normal of that slope, that will then give us the direction of our radius. So let's look at that. So dy dx at x equals 0, that equals -1. So I could rewrite that as -1 over 1. So that's not changing anything. So that equals our derivative. Okay, so we know the derivative is -1 over 1. So that would then entail that the slope is -1. So if you know the slope is -1 at the tangent, if we take the normal, then what we can do is we can find the gradient of that normal. So let's just have a look what's happening here. So that could be some origin. We've got the change in y is -1. So that will come down here. So that's -1. Then we've got the change in x is +1. So that would be represented by that. So that would then be our slope that we could be interested in, or our tangent. Now, if we want the normal of that, we need to just make a right angle and go in this direction to make that normal of our tangent. So that one then would have a change in y of -1 and a change in x of -1. So we could also bring them along here so we can see clearly. So therefore, what we've got there is our normal has a slope of -1 over -1. So that's what we've got. Now, what we can do now, if we want to find where the centre of the circle would be using that radius, what we do is now we set up our vectors x and y, and that would equal x at 0, so our starting point, so that's y at 0, and then what we do is we add on that the scalar multiple, which is our radius, which is √2 over 3, so absolute value of that, so that's √2 over 3, and then we can multiply that by our new points. So that's then -1 and -1. But we just got to be careful here. We need this length here to be just a value of 1. But using Pythagoras, we've got 1 squared plus 1 squared is 2. So this length here is square root of 2. So then we need to divide everything by square root of 2. So then we multiply this by another scalar, 1 over √2. And that will then give us where the radius will reach to of length √2 over 3. So at x equals 0, if we plug that into here, we get y equals +4. So our starting point is 0 and 4. Then we have the scalar multiple, √2 over 3 multiplied by -1 and -1, and then 1 over √2. Okay, so now let's multiply by the scalar multiples and this vector here, -1 and -1. So if we've got here √2 over 3 times -1 times 1 over √2, we'd end up with the -2's cancelling, and then we'd end up with -1 divided by 3. So then that equals 0, 4 plus -1 over 3. And then for our x, for our y coordinate, we'll end up with -1 times this again, so it's going to be the same. So it's -1 over 3. Okay, so now adding all that up, 0 plus -1 over √3. So therefore our x, y equals -1 over 3. And then 4 minus a third, that becomes 11 over 3. And that's a positive 11 over 3. So that'd be the centre of the circle, because that's where the radius would end. So centre is minus 1/3 and 11/3. So that's the centre of the circle for that radius. So now let's draw up the equation, take this off the board. So to find the equation of the circle, when we've got the centre and the radius, we know a general formula for that. So equation of a circle, and let's say we've got this circle here, and this point here, let's just put a line there for that. That's our coordinates a comma b, and we've got the radius r. We know that equation of that circle is x minus a squared plus y minus b squared equals that radius squared. That will give me the equation of that, with the a and the b being the centre of that circle. Well, we've got the centre of the circle, we've got the radius, so let's draw up that circle's equation. So now we've got x minus 1/3, so that becomes plus 1/3, and then we've got y minus 11/3, and that's squared, and then we've got root 2/3 as the radius. So if we square that, we've got 2/9, and that will be the radius of the circle found, centre of the circle found, and that's the equation of the circle using that coordinate there. And that completes the question.